For nearly half a century, Voyager 2 has been drifting farther and farther away from Earth, beyond the influence of our sun, beyond the comfort of known science. It was never meant to last this long, and yet, it still speaks quietly from the void. But this time, the message was different. What was decoded from the latest transmission didn't just surprise, it shattered the entire scientific community. A finding that was supposed to be impossible, a signature no one expected, a reality we may not be ready to face. What did Voyager 2 really find? How does it defy everything we thought we knew about the edge of the solar system? And why are scientists calling it the most haunting discovery ever made in space? Voyager 2 shouldn't exist. Its journey only became possible thanks to a once-in-176-year planetary alignment. Jupiter, Saturn, Uranus, and Neptune strung together like pearls on an invisible arc. In the 1960s, a part-time employee plotted those orbits by hand with nothing but a pencil. That discovery allowed engineers to use the gravity of each planet to slingshot the spacecraft toward the edge of the solar system, accelerating it farther than anything humanity had ever launched. Built with 69 kilobytes of memory, less than the key fob that opens your car, and transmitting with the power of a refrigerator light bulb, Voyager 2 was never designed to enter interstellar space. Yet, 46 years later, it's still out there, billions of miles away, whispering through the void. And now, it has whispered something strange. In 2018, Voyager 2 crossed the heliopause, the boundary where the sun's solar wind yields to the pressures of interstellar space. It followed its twin, Voyager 1, which crossed in 2012. But what Voyager 2 discovered at the threshold didn't match predictions. It didn't match anything. Scientists expected sharp changes in radiation, in magnetic fields, in plasma flow. But while the spacecraft recorded a massive spike in plasma density, proof it had reached interstellar space, the expected shift in magnetic orientation never happened. The field remained stubbornly unchanged, just as it had with Voyager 1. It was like stepping into a new room only to find the walls painted exactly the same as the one you left. That's not how physics is supposed to work, unless we were wrong about the shape of the room. For decades, we believed the heliosphere, the sun's protective magnetic bubble, ended at a certain point, wrapping us in a cocoon that separated home from the galactic wild. But Voyager 2's findings suggest that boundary is not a sharp border. It's a blurred, fluctuating frontier, turbulent, contradictory, and unlike anything theoretical models predicted. Voyager 2 didn't find silence beyond the sun's reach. It found strange fluctuations, ghost-like pulses of cosmic rays, plasma variations that don't match the sun's 11-year cycle. It's as if the spacecraft entered a place between places, a kind of magnetic twilight zone. And then came the impossible. Voyager's instruments detected a region of stable plasma and rising galactic radiation, without any corresponding shift in the magnetic field. According to our physics, that shouldn't happen, unless, of course, there's something interfering with our understanding, something bigger, something we are only just beginning to glimpse. Perhaps what's most incredible isn't just what Voyager 2 found, but how it found it. With 50-year-old computers, no AI, and heat-powered plutonium generators that lose 4 watts of energy per year, the spacecraft continues to function in temperatures it was never designed to survive. Engineers had already turned off critical systems like the heater for the cosmic ray detector to conserve power. Everyone thought the instrument would freeze and die. Instead, it kept working, far beyond its thermal limits, as if the machine refused to shut down before it delivered one last truth. Now, only 5 instruments remain active. By 2030, that number may drop to 0. But before that happens, Voyager 2 just made a discovery so strange, so precise, so wrong by all traditional logic, that it may rewrite what we know about the outer solar system. Because the edge we thought we knew, the end of our neighborhood, is not the end. And what lies beyond, Voyager 2 is trying to tell us before it's too late. Before the Voyagers, we believed the heliosphere was shaped like a teardrop, with the sun's influence trailing behind it like a comet's tail. But the data Voyager 2 is returning suggests a very different picture. A distorted, chaotic boundary that fluctuates wildly and may not be shaped by the sun at all. Instead of a clean break between solar space and interstellar space, Voyager 2 found overlapping zones of magnetic interference, sudden pockets of high-pressure plasma, and erratic radiation spikes. These weren't supposed to be there. They don't fit into any model. It's like trying to define the shape of a cloud with a ruler. Some physicists now suspect the heliosphere is being twisted and reshaped by galactic magnetic forces, pulled and pinched by interstellar winds we've never measured. Voyager 2, despite being 12 billion miles away, is sending back evidence that the sun's influence is not as dominant as we once believed, and that's more than a surprise. It's a threat. As Voyager 2 moves beyond the sun's protection, one thing becomes terrifyingly clear. Space is far more violent than we thought. Galactic cosmic rays, subatomic shrapnel launched by ancient supernovae, are no longer being filtered by the heliosphere. Voyager 2 is now exposed to them directly, and the data shows a disturbing trend. Not only is the radiation stronger, but it's structured, periodic, patterned. There are pulses in the data that some believe could be signs of interactions between cosmic rays and hidden interstellar structures, perhaps dense clouds of plasma, or worse, collapsed remnants of old stars drifting invisibly through space. This raises a chilling question. If even Voyager's hardened, heat-powered instruments are struggling to survive, what chance would human life have out there? These cosmic rays don't just burn through metal, they destroy DNA, they destabilize electronics. And as Voyager moves deeper into the unknown, it's revealing just how fragile we are in the face of the galaxy's raw forces. Each Voyager carries a message, a 12-inch gold-plated disc containing music, images, and greetings in 55 languages. It's been called Earth's mixtape, humanity's introduction, and our last letter to the universe. But here's what most people don't realize. Those records aren't just symbolic. They're our only real attempt to make contact with something we don't understand. They contain Chuck Berry, Beethoven, images of children, scientific data, and a message that reads, "This record represents our hope and our determination and our goodwill in a vast and awesome universe." Now, think about this. Voyager 2 has carried that message farther than anything human-made has ever traveled. And if there is something out there, conscious or not, it's listening to this. Not our strongest weapons, not our brightest minds, but our music, our greetings, our memories of home. And as Voyager's last instruments begin to fail, the record will be all that's left, floating, waiting, echoing a species that once looked to the stars and whispered hello. In its latest transmission, Voyager 2 detected something that should not exist. Scientists haven't publicly released all the data, but leaks suggest a frequency spike in one of the spacecraft's low-band instruments. A brief, repeating signal, not cosmic noise, not plasma vibrations. A signal that some insiders have described as mathematically consistent. It lasted only 2.4 seconds. It wasn't in any known modulation. It didn't match any solar or galactic source. And then, silence. The official explanation? An error, an anomaly, a glitch in the aging equipment. But off the record, some engineers aren't convinced. One was quoted saying, "It looked intentional. Not intelligent, but deliberate, like something meant to be noticed. Whatever it was, it hasn't repeated. But the fact that it happened once, that it was captured, archived, and confirmed, has changed everything. Because if Voyager 2, with its failing power, ancient circuits, and fading voice, can still intercept something that breaks every rule we've written about deep space, then what else is out there that we haven't heard? Because we weren't listening? Voyager 2 is more than just a spacecraft. It's a mirror, one we launched into the cosmos, not to look back at us, but to remind us of what it means to reach beyond our limits. Everything about it was improbable, built by hand, coded in assembly, operated by teams who have long since retired or passed away. And yet, it endures, not because it was perfect, but because it was human. It represents a time when we dared to explore, not for profit or power, but for the pure desire to know, to understand, to ask questions that no one else was asking. And now, 46 years later, that same machine is still asking those questions for us, quietly, humbly, from a place no human has ever seen. It is transmitting the conditions of interstellar space, the music of plasma, the whispers of ancient starlight. Not because we told it to, but because it's still able to. In doing so, Voyager 2 reminds us of something we've forgotten in our world of distractions and instant gratification, that the universe doesn't need to be loud to be profound, that the greatest discoveries don't come in explosions, but in echoes, and that sometimes the smallest signal from the farthest place says more about us than all the noise here on Earth ever could. Voyager isn't just telling us about space, it's telling us about ourselves, about what we've done, what we've left behind, and maybe what we still have time to become. In the coldest, darkest corner of space, where sunlight is just a memory and gravity barely whispers, a tiny machine built by human hands is still speaking, against every prediction, against every limitation, against time itself. Voyager 2 continues. But this last discovery, it wasn't just science, it was something else. A tremor, a reminder, a clue. Something we were never supposed to receive, or maybe something we were always meant to hear. Because this journey was never just about reaching space. It was about proving we could reach beyond ourselves, that we could build something that mattered, even when no one was watching. That curiosity could outlive politics, noise, and ego. Voyager 2's signal is fading, its power is dying. But before it goes silent forever, it gave us one final truth. That the universe is not empty, that the edge isn't the end, and that sometimes the most impossible discoveries don't break our science. They awaken our imagination. And now we ask you, what do you think Voyager found? Was it science, or something we've never dared to name? Was it just a cosmic coincidence, or the beginning of something bigger? Let us know in the comments. If this story moved you, inspired you, or made you look at the stars a little differently, subscribe and hit the bell, because we're just getting started. There's more out there than we've ever imagined, and Voyager was just the beginning. The whispers from the void grow stranger by the day. As Voyager 2 ventures deeper into uncharted territory, its aging instruments continue to send back data that challenges our fundamental understanding of the cosmos. The latest readings reveal something even more perplexing: anomalous energy fluctuations in regions that should be completely dark and silent. These aren't random cosmic background signals. They're structured, organized, as if the very fabric of interstellar space itself is vibrating in ways our physics can't explain. Scientists are scrambling to interpret these findings. The spacecraft's plasma wave instrument, designed in the 1970s with technology less sophisticated than a modern calculator, has detected rhythmic pulses in the interstellar medium. These pulses occur at intervals that don't correspond to any known cosmic phenomenon. Not solar flares, not pulsar emissions, not even the mysterious fast radio bursts that have puzzled astronomers for years. The patterns are too precise to dismiss as instrument noise, yet too alien to fit into any existing astrophysical model. Some researchers quietly speculate these could be signatures of an entirely new class of interstellar phenomena, perhaps interactions between dark matter and ordinary matter, or evidence of massive unseen structures warping the fabric of space itself. What makes these discoveries even more astonishing is the spacecraft's improbable endurance. Voyager 2's power output has dwindled to just a few watts, barely enough to keep its remaining systems alive. Yet somehow, its cosmic ray subsystem continues to detect particles with energies that shouldn't exist so far from any known cosmic accelerator. These aren't just random high-energy particles. They're arriving in clustered bursts, as if something out there is funneling them toward the spacecraft. The implications are staggering. Either our models of particle propagation through interstellar space are fundamentally flawed, or Voyager 2 has stumbled upon a cosmic particle accelerator of unimaginable scale, one that operates without any visible source. The magnetic field data tells an equally bizarre story. While scientists expected the interstellar magnetic field to be smooth and uniform, Voyager 2 has found it to be turbulent and strangely knotted. These magnetic kinks don't behave like anything observed in our solar system. They twist and recoil like living things, creating pockets of intense magnetic energy that appear and disappear without warning. Some theorists suggest these could be remnants of ancient supernova explosions, frozen magnetic fossils from stellar deaths that occurred millions of years ago. Others propose something far more radical, that we're seeing the fingerprints of quantum-scale phenomena manifesting on an interstellar scale, a blurring of the line between the very small and the impossibly large. Perhaps most unsettling of all is what Voyager 2 isn't detecting. As it moves farther from the Sun, the spacecraft should be entering a region dominated by the Milky Way's ambient radiation field. Instead, certain frequencies are eerily quiet, too quiet. It's as if something is absorbing or blocking specific wavelengths of interstellar radiation, creating unnatural shadows in the cosmic background. These voids in the electromagnetic spectrum don't match predictions for any known absorption mechanism. The only comparable phenomena occur near certain types of black holes or neutron stars, yet Voyager 2 is light years away from any such object. The spacecraft's plasma spectrometer tells yet another mysterious tale. While interstellar space was expected to contain a thin, uniform soup of charged particles, Voyager 2 has found the plasma to be clumped into dense filaments separated by vast empty regions. These filaments aren't random. They appear to align along invisible pathways, like beads strung on cosmic strings. Some researchers whisper about the possibility of these being traces of the universe's large-scale structure, the cosmic web of dark matter that theoretically connects galaxies across the void. If true, Voyager 2 might be giving us our first direct measurements of this hidden architecture of the cosmos. Time is running out to solve these mysteries. With each passing day, Voyager 2's power dwindles further. Engineers have already performed miraculous feats to keep the spacecraft alive, inventing new ways to manage its fading energy reserves. They've turned off heaters, rerouted power, and even found ways to use the spacecraft's own waste heat to keep critical components functioning. But the laws of physics are unforgiving. Within the next few years, the last of Voyager 2's instruments will fall silent, leaving the spacecraft to drift eternally through the interstellar dark, a mute witness to wonders we may never fully understand. Yet, even in its twilight, Voyager 2 continues to redefine what we know about our place in the universe. Every new data transmission forces us to reconsider old assumptions. The boundary of our solar system isn't the clean, orderly transition we imagined. It's a chaotic, dynamic frontier where unknown forces shape the environment in ways we're only beginning to comprehend. The interstellar medium isn't the quiet, uniform expanse textbooks described. It's alive with structure and mystery, filled with phenomena that challenge our very definition of empty space. As we await Voyager 2's final transmissions, one truth becomes increasingly clear. We built this machine to explore the unknown, and in its final years, it has shown us just how much we didn't know. The spacecraft's greatest legacy may not be the answers it provided, but the questions it revealed, questions that will drive exploration for generations to come. In the vast darkness between stars, our tiny messenger continues its lonely journey, showing us that the universe is far stranger, far more wonderful, and far more mysterious than we ever dared imagine. And somewhere out there, in the endless night between the stars, Voyager 2 carries not just our science, but our dreams, proof that even in the face of the unknown, humanity will always reach for the stars. Its fading signal reminds us that exploration doesn't end when the power runs out. It simply changes form, from electrical pulses to eternal drift, from active observation to silent witness, from spacecraft to cosmic artifact. Long after its last transmission fades, Voyager 2 will continue its journey, carrying with it the best of who we are, our curiosity, our courage, and our unshakable belief that there are always new frontiers to explore. The impossible encounter at the edge of the solar system was just the beginning. The real discovery is this: